I want you to think of multiplying special cases as kind of like a bonus lesson. If you remember these special cases, that is great. It's going to save you time. However, if your brain is on overload, you can always FOIL out these binomial expressions that you're multiplying, and then you'll probably notice, oh yeah, this is one of those special cases. So I'm going to be presenting these as you can apply the shortcut that I'm going to show you, or you can FOIL it out as you did last lesson and you will be completely fine. Our target is that we can square binomial expressions. So first let's start with the square of a binomial. Notice I have a plus b times a plus b. So this could be written out as a plus b squared. It's the same thing as having a plus b times a plus b because my base is a plus b. So if you were to FOIL that out, your first multiplying would be a times a, which is a squared. Then the outside terms would be a times b, which is ab. Then your inside terms would be b times a, which is ab. Then your last terms would be b times b, which is b squared. So when you simplify that, the AB and the AB are combined to be 2AB. So your resulting expression is a squared, whatever that first term was, plus 2 times both of the terms, plus the second term squared. So to sum that up, the square of a binomial, you're going to have the square of the first term, which is where you have a squared. You're going to have twice the product of the two terms, 2 times the a and the b. And then you're going to have the square of the second term, b squared. Let's see this actually played out. Let's take n minus 7 squared. First, let's FOIL it like you saw last lesson and what you're probably more comfortable with. The first terms, n times n, would be n squared. The outside terms, n times negative 7, would be negative 7n. The inside terms, negative 7 times n, would be negative 7n. And then the last terms, negative 7 times negative 7, would be positive 49. Then I can combine like terms of negative 7n and negative 7n. So I'm left with negative 14n plus 49. Okay, let's apply the shortcut. The shortcut says I have the square of the first term, n squared. I have 2 times the first term and the second term. So 2 times n is 2n. 2n times negative 7 is negative 14n. And then I have the second term squared, negative 7 squared. Negative 7 times negative 7 is positive 49. So you can definitely see how this is a shortcut. However, like I said, if your brain is on overload and you cannot remember a single more rule, you can still FOIL it out, and then you're like, oh yeah, this is one of those special cases. I'm basically doubling the AB term, and then I'm squaring the first term and the last term. Either way, it definitely works. Here, let's apply this to mental math. So you have 35 squared. So we are going to rewrite that as 30 plus 5 squared. See how this is a binomial squared. So we're going to be like Ed Sheeran and we're going to do some thinking out loud here. Ha ha ha. The shortcut would be that I square the first term. So I'm thinking, oh yeah, I have 30 plus 5 squared. I did 30 plus 5 because I can square 30 in my head, I can square 5 in my head, but I cannot square 35 in my head. So this is how it applies to mental math. The first term squared, 30 times 30 would be 900, plus 2 times the first term and the second term. So 2 times the first term is 60. 60 times 5 would be 300. Plus, I'm going to have the square of the last term, which is 5 times 5, 25. So I can add all that up. 900 plus 300 is 1,200, plus 25 would be 1,225. If you have a calculator nearby, I totally realize it's quicker to type in 35 squared, but if you don't and you're trying to think about this in your head, you can apply this square of a binomial rule to mental math when it's just numbers like this and do that in your head. Now let's look at our other special case. I call it the difference of two squares, and probably most algebra teachers call it that. For some reason, your book calls it the product of a sum and a difference. That's just a lot of more math words. The difference of two squares. So the difference meaning I have this one adding and this one is subtracting. I can't write it with an exponent on the outside because the base is different. So the numbers, or the monomials, the terms there are the same. It's an A and an A, a B and a B. But I have a plus here and a minus here. So this would be like if I had n plus 4 times n minus 4. The difference is the adding and the subtracting. Outside of that, they are the same. So I would square the first term if I were to FOIL this out, which would be a squared. The outside terms would be a times negative b, which is negative ab. Then I have the inside terms, positive b and positive a, which is positive ab. And then I have the last terms, positive b times negative b, which would be negative b squared. Negative ab and positive ab cancel out. So what you're left with is a squared minus b squared. In words, you are squaring the first term minus the square of the second term. You only end up with two terms instead of three terms like what you're used to because the inside and the outside products end up canceling out. So the shortcut is you square the first term and then you subtract the square of the second term. Let's compare the FOILing and the shortcut likewise with the difference of two squares. So let's FOIL here on the left. First terms, 3c times 3c would be 9c squared. The outside terms, 3c times positive 4 would be positive 12c. The inside terms, negative 4 times 3c would be negative 12c. And the last terms, negative 4 times positive 4 would be negative 16. 12c and negative 12c cancel. So I'm left with 9c squared minus 16. Now let's say that I recognize, oh, this is the difference of two squares, and I'm going to be able to use my shortcut. I'm going to square the first term. So in my head, I'm thinking 3c squared. And based on our exponent rules, that square is applied to the 3 and the c. So I have 9, which is 3 squared, c squared. And then I'm going to square the second term, and I'm subtracting it. 4 squared is 16. Both ways get me there. It's just a matter if you recognize the shortcut or not. If you don't recognize those shortcuts, it's fine. You FOIL it out, and then your brain at the end says, oh yeah, that was one of those special cases.